Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So now we are discussing about engineering typology subject. So today's topic is lubrication regimes. So in the previous session, already we have discussed about friction, lubrication, friction wear, and lubrication. We are discussing lubrication properties and what are the characteristics of lubrication we have learned in the previous session. So in this today's topic, we will see how many types of lubrication systems are there. So what is this lubrication system and what is the importance of these lubrication regimes? We will learn in this session. So before going to today's topic, we should recall the lubricant and what are the functions of lubricant once again. So the lubricant is a substance used in between two moving surfaces to reduce the friction. The main aim of the lubricant is to reduce the friction between two meeting surfaces. So whenever two contact surfaces are in relative motion, there must be a friction, there must be a wear. So in particular situation, you need to use the lubrication to reduce the friction. So by using this lubricant, somewhat you can control the failures. The lubrication means it is a process of reducing friction and wear between two moving surfaces by adding lubricant in between them. So that process is called lubrication process. So what are the functions of a lubricant? So the main function of the lubricant is it prevents the direct contact between the moving surfaces and reduces wear, tear, and surface deformation of the concerned parts. And the next function is to it reduces the wastage of energy so that efficiency of the mission enhance. So you can reduce the wastage of energy. It leads to improve the mission efficiency. So it reduces the frictional heat and prevents the expansion of metals. It acts as a coolant by removing the frictional heat generated due to the rubbing of surfaces. So whenever two surfaces are in a mating position, there must be a friction due to the heat generation. So the heat must be dispersed to the surrounding area. So by using this coolant, the lubricant act as a coolant, the removing that the frictional heat from the main source and transfer to the surroundings. So due to this, you can maintain the sufficient heat for inside the component or rubbing surfaces. So by doing this type of process, you can avoid the failures. So it minimizes corrosion. It provides cleaning action. It provides a cushioning effect. Sometimes the lubricant used as a cleaning action, used as a cushioning effect. For smoothing, smooth vibrations. To avoid the high vibrations, you can use this lubricant. It acts as a damper. So these are the functions of a lubricant and the lubrication process and lubricant we have seen. So this is the main lubrication system. So different types of systems are there. So but this is for engine lubrication system. So the engine lubrication system in the engine, many parts are there like connecting rod, crankshaft, and piston pins. Okay, and flywheel. So timing gear. So like this, many parts are there. All parts require some lubrication to work effectively and to enhance the efficiency of the engine. So the main source of lubrication poured into this oil pan. From this oil supplied to various lubrication systems, to various parts to with the help of lubrication system. So cylinder head and valves and the crankshaft, rocker arms you can see in this diagram. So this is the supply of the lubrication to various systems. So this is one type of lubrication system diagram shown. Okay. So now, so how it will supply the lubrication? So what are the main important types, important reasons of lubrication? We will see in coming up slides. So the lubrication reasons refers to the different conditions under which lubricant operate to reduce friction and wear between moving surfaces. So it mainly focus on lubricant different conditions under which lubricant operate at particular moving surfaces to reduce the friction. Which type of lubricant required? So according to type of speed, load, and type of motion between the surfaces. So mainly the classification according to the type of load, type of speed, and the type of motion between the surfaces. They classified into different types. We will see in the next slide. So understanding these reasons is crucial for selecting the right lubricant and ensuring proper machinery operation. So understanding of these systems is very crucial for selecting the right lubricant. Clear. So which type of lubricant is required for for a particular system? Which type of lubrication system is required for a particular moving surfaces? So this is very difficult to understand. So the primary lubrication regimes are one is boundary lubrication. The first important reasons in lubrication is boundary lubrication. What do you mean by this lubrication? Boundary lubrication means in this type of boundary lubrication, there is direct metal to metal contact between the surfaces. So there is no gap between the metal to metal, so that some metal contact between the surfaces with only a very thin film of lubricant separating them. So in this, only thin film of lubricant separate this metal to metal contact. So supposing the bearing, so the general bearing like this. So the lubrication supply, this is general. So the lubrication is supplied like this. So this thin film, this thin film separates these two surfaces. So otherwise, there is a metal to metal contact like this. Okay. So the conditions are low speed, high load, and uh, and poor lubricant properties. So that's why you should maintain the lubricant. You should learn lubricant properties. What are the important properties of lubricant, and what are the characteristics of lubricant? You must understand. Characteristics: high friction and wear. The lubricant's main function is to provide a protective layer between the surfaces. So the lubrication, whenever the lubrication oil is entered in this gap, there is uh, the formation of film that is very thin film between these two surfaces. So somewhat you can minimize the metal to metal contact between the surfaces. So this type of lubrication system is called boundary type lubrication. This reasons is the most undesirable since it is characterized by high coefficient of friction, increased wear, possibility of seizure between the bearing and general materials. So non-uniform distribution of the bearing load. So localized pressure peaks are there. So very severe engine bearing failures are caused by boundary lubrication. So due to this type of bonded lubrication, there is a bearing failures, the severe engine bearing failures are there. So this is the possibility of seizure between the bearing and the general bearing, general materials. So suppose whenever there is no proper lubrication between these two metal to metal contact surfaces, there is the seizing effect will be occurred. So due to this lubrication, improper lubrication. So non-uniform distribution of a bearing load. There is no constant bearing load. There is non-uniforming the uniform distribution of load also there, the bearing load. So all these leads to severe bearing failures. The second one is hydrodynamic or fluid film lubrication. So in this reason, a thick film of lubricant completely separates the moving surfaces. The moving surface, suppose one is bearing, another one is journal. So, okay, bearing and this is journal. So, there is a metal to metal contact. Whenever the metal to metal contact, there is a thin film lubrication is possible in the case of bonded lubrication. In the aerodynamic, the thick film of lubricant completely separates the moving part. So completely separates this lubrication, this journal and bearing, completely separate. So there is a the maximum film thickness of film. So the lubricant film is generated by the relative motion of the surfaces. The high speeds conditions and moderate to low loads. What are the characteristics? Low friction and wear. The lubricant film supports the load and prevents direct metal to metal contact. Uh, in this case, you can avoid the metal to metal contact completely. There is no metal to metal contact. Why? Because the formation of film, the thick the lubricant film is here thick film lubrication, thick film lubrication. Clear. Hydrodynamic lubrication, also called fluid film or fluid lubrication. The very severe engine failures are not happened here. So this is in the case of hydrodynamic, in the case of bonded lubrication possible. The somewhat failure is there. There is not severe failures. Why? Because the proper lubrication also possible in this hydrodynamic lubrication. That's why this lubrication is called a fluid film lubrication. Next, mixed lubrication. So in this type system, the combines elements of both boundary and aerodynamic lubrication. Boundary lubrication already we have seen, and aerodynamic. The combination of these two lubrications gives the mixed lubrication. So in this, a partial film of lubricant exists between the surfaces, but some metal to metal contact can still occur. So in aerodynamic boundary lubrication, metal to metal contact there. In this, the partial film of lubricant. So this is combination of these two, aerodynamic and boundary. So exist between the surfaces. So the conditions of moderate speeds and loads where boundary and hydrodynamic effects are both present. So wherever the high speeds, moderate speeds and moderate loads are where boundary and aerodynamic effects are present, there must be a mixed lubrication reasons is present. The characteristics, the intermediate friction and wear, both the lubricant film and the direct contact between surfaces play a very critical role. Next one is allows to hydrodynamic lubrication. So in this case system, it occurs when there is a significant deformation of the surfaces due to the high pressures and temperatures generated by the lubricant film. So whenever the lubricant film generates temperature, high pressure, so there is hydrodynamic lubrication, the deformation possible. So it is very high pressures, high speeds where the lubricant film thickness is less than the surface roughness, and the characteristics are extremely low friction and wear due to the elastic deformation of the surfaces and the lubricant film pressure generation. So this type of lubrication system is called allows to hydrodynamic lubrication. So due to the high pressures and temperatures generated by the lubricant film. So due to the uh, elasticity property, the surfaces the deformation will be possible. Clear. So this type of system mainly depends upon the properties of the material. Very very important here in this case. If you don't know the property of the material, you can't use proper lubrication system for the particular application. Next one is boundary mixed lubrication. So this is a transitional design between boundary and mixed lubrication. It occurs under varying conditions where both direct contact and partial lubricant film exist. The conditions, changing speeds and loads, are when the lubricant's properties are not constant. The characteristics are varying friction and wear depending on the operating conditions. This is the type of lubrication system is called boundary mixed lubrication. Choosing the right lubrication regime and lubricant type is essential for maximizing machinery efficiency, reducing maintenance cost, and extending equipment life. So, if you are selected the proper lubrication system for the particular application, you can improve the machinery efficiency, you can reduce the maintenance cost, and you can improve the extending equipment life. So that's why you must understand the lubrication reasons. It requires considering factors like operating conditions, equipment design, material compatibility, and lubricant properties. So these three factors are very very important. They're like operating conditions, equipment design, material compatibility, and lubricant properties. Next one is solid lubrication. So in this solid lubrication and dry or marginally lubricated contacts are important topics in tribology. The science of interacting surfaces in relative motion. So tribology already you know this. It is a science of interacting surface in relative motion. They involve three factors. One is friction, second one is wear, and third one is lubrication. So wherever the tribology subject involves this relative motion, there the solid lubrication and dry or marginally lubricated lubrication system understanding is important. So solid lubrication involves using solid materials to reduce friction and wear between the two surfaces in contact. Already we have discussed in previous sessions. So unlike liquid lubricants, solid lubricants remains in a solid state under operating conditions. Some common solid lubricants are shown here. One is graphite. So here a form of carbon that can be used as a dry lubricant due to its lamellar structure, which allows it to slide easily between surfaces. Graphite. The molybdenum disulfide, so you can develop MOS2. Another popular dry lubricant that offers low friction and good wear resistance. And third one, tungsten disulfide, similar to MOS2 but with some differences in properties. Tungsten disulfide. The next poly tetrafluoroethylene, known by a brand name Teflon. PTFE is a synthetic polymer that can be used as a solid lubricant due to its low friction properties. So these are the some types of solid lubricants. Next, dry and marginally lubricated contacts. So dry and marginally lubricated contacts refer to situations where either no liquid lubricant is present or the amount of lubricant is insufficient to fully separate the contacting surfaces. In these conditions, the surfaces may experience high friction and wear compared to fully lubricated contacts. So this type of contacts are happen in dry and marginally lubricated system. So the dry contacts, there is no liquid or no solid lubricant is present between the two contacting surfaces. So this can lead to high friction. So whenever two contact surfaces are in a relative motion, there must be friction. But to avoid friction, you have to use some lubricants. But in a dry contact type of lubricants, there is no lubricant present physically, the liquid or in a solid form. This can lead to high friction, in increased wear, and potentially surface damage will be occurred. To reduce friction and wear in dry contact, solid lubricants or surface treatments can be applied to the surfaces. And that time you can use these type of solid lubricants like graphite, molybdenum sulfide. So solid lubricants you can use in between the two contact surfaces to reduce the friction and wear. So the marginally lubricated contacts, the small amount of liquid lubricant may be present, but it is not sufficient to fully separate the surfaces. So whenever the fully sufficient lubricant is present in between the two contact surface, there is the full separation of the two surfaces. So that means there is no metal to metal contact is possible, but in this case, no sufficient fully separate the surface. Insufficient lubricant present in the two contact surfaces. So there is a so marginally that separate the surfaces that are marginally lubricated contacts. This can occur in situations where the lubricant film is very thin, or the operating conditions such as that lubricants is squeezed out from the contact area. So whenever relative motion is there, whenever started to rotate the journal inside the bearing, there is a squeezing effect. The squeezed out from the contact. So some wastage of lubrication spill out to the surroundings. So under these conditions, there is a insufficient lubrication present in between the surfaces. So the marginally lubricated contacts can also experience increased friction and wear compared to fully hydrodynamic lubricated contacts. The fully hydrodynamic lubricated contacts, there is a sufficient lubrication either in the form of liquid or solid in between the contact surfaces. Just the importance of so this lubrication designs, understanding the solid lubrication and dry or marginally lubricated contacts is crucial for designing and operating machinery and mechanical systems efficiently and reliably. So the understanding of solid lubrication, dry marginally lubricated contacts is very crucial for designing of machinery. Uh, So if you want to design a machine, that should be work efficiently. So otherwise, there is no use, and the cost also will be high. The proper lubrication can significantly reduce friction, wear, and energy consumption. So leading to longer component life and a lower maintenance cost. So that's why you should learn the lubrication system and lubrication process and the lubrication properties. Next topic is Stryberg curve. So in this, we will see the comparison of these three lubrication regimes. The three lubrication regimes are clearly distinguished in the Stryberg curve. You can see the figure in the next slide, which demonstrates the relationship between the coefficient of friction and the bearing parameter and the dynamic viscosity of the lubricant. So you can use like this, and we use the formula bearing parameter, and n is the rotational speed, and p is the average the bearing pressure, and viscosity. The eta is the dynamic viscosity of lubricant. The stability of different lubrication regimes may be explained by means of the Stryberg curve. So in this curve, you can see this curve represents the coefficient of friction versus this the bearing parameter. The bearing parameter is called eta n by p. So here different types of lubrication systems shown: the for boundary lubrication, mixed lubrication, and aerodynamic lubrication. So how the coefficient of friction vary with the value of bearing parameter. So this curve is called as a Stryberg curve. So in this, see the boundary lubrication, there is a metal to metal contact, very thin layer of lubrication is present. In this mixed lubrication, somewhat separation is there between the two surfaces. In hydrodynamic, fully separated with maximum thickness, that is maximum film thickness, that is you can represent it with H. The velocity and whenever force loaded the bearing or rotating parts, you can see the variation of lubrication in this figure. So in this figure, the temperature increase due to the heat generated by friction causes drop the lubricant viscosity and the bearing parameter. So according to the straight back curve, decrease of the bearing parameter in mixed region causes increase of the coefficient of friction. The followed by further temperature rise and consequent increase of the coefficient of friction. Thus, mixed lubrication is unstable. So in this curve, whenever decrease of the bearing parameter, see decrease of the bearing parameter here, the bearing parameter, you can increase the coefficient of friction is chances are there. So here, whenever this decrease, uh, whenever this bearing parameter is decrease, the coefficient of friction followed by further temperature rise and the consequent increase of the coefficient of friction. So next, increase of the bearing parameter due to temperature rise. So that means lower viscosity in hydrodynamic regions of lubrication causes the coefficient of friction to drop with consequent decreases of the temperature. So the system corrects itself. So thus the aerodynamic lubrication is stable. So that in this, so whenever the increase of the bearing parameter due to the temperature rise, the aerodynamic region of lubrication causes the coefficient of friction to drop with the consequent decrease of the temperature. So in this diagram, the system corrects itself only. So you can see the change of this curve from boundary lubrication to hydrodynamic lubrication. So with this bearing parameter. So these are the references I've taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.